Hey everyone, welcome back to the channel. In today's video, we are diving deep into one of the most powerful ensemble technique in machine learning, stacking. You will learn how stacking works, why it is so effective, and we'll walk through a hands-on example using Python and scikit-learn. Let's get started. So before we jump into the code, let's quickly understand what stacking is. So stacking is an ensemble learning method that combines multiple models to improve prediction performance. Unlike method like bagging or boosting, where you use the same type of models, stacking uses different models called a base learners to make predictions. And the final model is then made by a meta model that learn how to best combine the prediction of these base learners. The idea is that different model may capture different pattern in the data, so combining them give us more robust, accurate prediction. Stacking is often the secret sauce for winning machine learning competition, as it allows you to leverage the strength of the diverse model. Let's break down the workflow of this stacking. So the step one is train the base model. So we'll start training several different models on your training data, right? If there's a training data, these are different models, and these models can be like decision trees, support vector machine, or even neural networks. Second, create a meta function. So meta function is it's a base. Each base model makes prediction on the training data, and these prediction becomes the input for the meta model. And this is the key because the meta model learns to combine these prediction to improve accuracy. Finally, the meta model, often a simple linear model like logistic regression, is trained on this base prediction, and it makes the final prediction like this. So this is what stacking is. All right, now let's we understand. Now that we understand the concept, let's see how to implement stacking in Python. We'll use the popular scikit-learn library for this, and our example will be will use the iris dataset. A simple classification problem. Let's start by setting up the environment. We'll load these libraries. Next, we'll load the data and we'll split it into training and testing data. And let's move on to define our base models. So if I run the load data and split the data, and these are the base model, decision tree classifier, SVG, and logistic regression. So let me run this. Now that we have defined our base model, let's create the stacking classifier, which will use our logistic regression model as the meta model. So here we are using the logistic regression model as a meta model. And now with the stacking model ready, let's train it on the training data. So if I run this, so as you can see, these are our base model. This is our final estimator, logistic regression. And now training is done. Let's evaluate the performance. And as you can see, it's fun because of the small data set. We want to understand the concept of the stacking. So result is not so important. And if I just run this, evaluate each base model, so every base model is predicting the one only. So here's the output of model evaluation. As you can see, the stacking models performs and how it's perform using the base models, and also how the meta model is used to learn how to combine the strength of the base learners. As expected, the stacking gave us the almost perfect accuracy, and it's a great reminder that combining models can often outperform the single model, especially when the base model are diverse. Yep, that's all for the today's tutorial on stacking in machine learning. We have seen how the stacking combines different models and how it can boost performance. If you enjoyed the video, make sure to give us a thumbs up. I'll see you in the next time. Thank you.